In working through this problem, the first thing I'm going to do is write the equilibrium expression. The reason why ICL is squared is because of the coefficient 2 that's in front of ICL in the problem. And we always write the products on top, so the forward reaction over the reverse reaction. So then in the process, we need to figure out which direction the reaction is going. Is it at equilibrium? Is it going forward? Is it going in reverse? And we find that out by calculating Q. So we notice that they give me 4 moles per 1 liter of each substance. So I'm just going to go ahead and make a Rice equation so I know that that's R. So I'm going to make a Rice table. I know initially 4 moles per 1 liter is 4 molarity. So I have 4 molarity that tells me of each substance. So I have 4 molarity of each species. So if I plug that in and solve for Q, so I know that Q is just what my initial concentrations are, which are 4. So I know I'm going to have 4 squared divided by 4 times 4, which is also 4 squared. So I know that Q is 1. Well, how does that compare to K, which is 0.1? So I kind of like to set up a number line. So I know I'm at 0.1 for K. I'm at 1 for Q. So I've noticed I've gone past equilibrium. So my reaction is going to need to go backwards. And so in the process of working the problem, that's going to help me with my C line. So on the change line, I know it's always about X amount of each of the substances, or the coefficient times X amount. So in this case, I know I'm going to lose or gain X amount of I, X amount of Cl2, and 2X, because again, the coefficient 2 in front of the ICL, amount of ICL. But then I know that since Q is greater, then I'm going from products back to reactants, which means I'm going to lose product and I'm going to gain reactants. So those are going to be my pluses. So then at equilibrium, I know that I'm going to have 4 molarity plus X amount, 4 molarity plus X amount for Cl2, and then 4 minus 2X amount for ICL. So what that's going to do is it's going to let me set up now and plug in and actually solve for X. My goal is not just to find X, but to plug it back into my equilibrium line to figure out my equilibrium concentrations. And so I'm just going to plug everything into the equilibrium expression. So I know that ICL is 4 minus 2X, and it's squared because of the 2. I'm going to then plug in I2, and being that I2 and Cl2 are the same value, I can just do 4 plus X squared. The perfect square is a great way to work it. We don't have to worry about the quadratic equation. So what I'm going to do is square both sides, or take the square root of both sides to get rid of this little squares that I have. And so I know the square root of 0.1 is 0.32. And then I work out this, which is now 4 minus 2X over 4 plus X. So then I'm just going to go through the process and isolate X. So 0.32 times 4 plus X is equal to 4 minus 2X. I'm going to distribute the 0.32. So 0.32 times 4. I have to kind of find my way here. Is 1.28. Kind of got over a little bit too far. 1.28 plus 0.32x. And that's still going to equal 4 minus 2x. Then I'm going to combine terms, and so I'm going to move the 1.28 to the other side and move the minus 2x to the other side. So I'm going to end up with 2.32x and 2.72. And then I'm just going to solve for x. So I'm going to divide both sides by 2.32. So I end up with x equaling 1.17. So then I'm just going to take that value and I'm going to plug it nice and neatly back into here. So I know that x is 1.17. and then 2 times 1.17. And then I just find the values. So this is going to be 5.17 and its molarity. This one's also 5.17 molarity. And then when I take 4 minus the 2 times the 1.17, I get 1.66 molarity. So those are my final answers for the equilibrium concentration of each species.